Does anyone know what we're supposed to be doing right now?
I think we need like the slide or something like that. Does anyone have that?
I have a slide. Did you guys see this? I don't know what to do with it. I mean, it says we're supposed to draw acetate. So maybe just like everyone draw acetate real quick.
Sure, yeah.
I got this. Did you guys get this?
Yeah, kind of.
Okay.
Yeah.
Nice smiley face. Okay. Okay, good. Thanks, you guys. I guess we should go back now. Breakout room 1, what did you guys talk about? Is anyone there? Breakout room 1?
So we're not sure. I think Kimberly.
Oh, am I supposed to be the reporter? Yeah, we drew the Lewis structure all together and compared our answers, and yeah, everyone seemed fine with it.
Do you want to show us your answer?
I think I lost it after I left the breakout room. The whiteboard looked like stuff.
Oh, okay.
Did someone else in the group draw it on paper? Sorry, guys.
Yeah, so I was manager last time. Can someone else be manager?
Sure, I haven't been manager in a while. I can do that.
Awesome. I can do recorder. I have the slide ready to go, so I can record that.
Okay, I can do the question.
That leaves me to be the reporter. Okay, sounds good.
Okay. Okay, good. I'll share my screen.
Awesome.
I have the PowerPoint slide. It says we're supposed to draw the Lewis structure for the compound, thinking out loud with our group, and then describing each step in the process. And so it's CH3COO minus. Okay, so I'll go ahead and pull up the whiteboard so that we can do that. And then you guys can just tell me what I should draw.
So I think we want to probably start out with the carbons in the middle.
Yeah, carbons usually go in the middle, right? And how many carbons were there again? 2?
Just 2, yeah.
So we'll put those.
And then we need to. Let's do the other atoms first, then we'll do valence electrons.
Mm-hmm.
The hydrogens around the one carbon.
Okay, yeah. Sorry, I'm a little slow with the drawing. It's not that bad though.
Good.
It's like legible, so I'm getting better.
And then we've got 2 oxygens. I think they're attached together like in a chain on the end.
Like over here?
Yeah.
Okay, yeah.
I think the oxygens should each be connected to the other carbon and not be connected to each other.
So this last one, what should I do with that one? Just erase it?
It would go connect to the other carbon, to the carbon.
Like on top?
Yeah, right.
Okay, I'll put it there. Okay, good.
Then next step is valence electrons, right?
Yeah. So like 3 valence electrons from the hydrogens, and then carbon is 4, so that's 7, and then 11, and then these are each 6, so that's hard. That's 23, right? And then it's COO minus has a charge, so then 24 electrons. Do you agree?
Yeah.
Okay. So then we start with the single bonds, right? So we'll just put single bonds between all of them.
Right. And then, Kimberly, could you help us maybe count up the electrons as we go?
Yeah, so right now we need to count up the ones in the bond, right, and subtract that from the total. So we have 2, 4, 6, 8, 10, 12 that we've used so far.
Uh-huh. So we've got 12 left.
Right.
And then normally you put them on the middle atoms, right? But I guess we can put some here on this carbon. That's the only one that can have more little electrons on it. And then we put them on the outside, so on the oxygens. So that's 2. These are kind of hard to draw. I'm going to try and just, okay. How many is that? 2, 4, 6, 8.
There's just only 4 left.
Yeah, so we can only put 2 on that oxygen.
Yeah. Okay. So that's not good because the oxygen doesn't have an octet, right? So
Maybe that's, I don't know, what do you think, Claudia?
So we can make a double bond now. I can put the carbon and one of the oxygens.
okay, so I'll try erasing these guys from the carbon, and then I'll just draw the other bond here.
Yeah.
Okay, and then let's check and make sure that everybody has an octet. So like this is 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and then 2 for each of the hydrogens. So that looks good.
I agree.
It has the negative charge though, right? And so, wait, did we check? Do we have the 24? We have 24 electrons. Did we check that?
Yeah.
Okay. So, where do we put the charge?
Yeah, formal charge. That's right.
So is that on this oxygen or this oxygen?
Let's see. How do we calculate formal charge again, guys?
So it's number of valence electrons minus so it's like you count the lone pairs, each electron in the lone pair counts as 1, each bond counts as 1, and then you subtract that from, so you take the number of electrons it starts out with. So oxygen started out with 6, and then we're going to subtract each lone pair electron.
So this is like 6 here, right? Like 1, 2, 3, 4, 5, 6.
Yeah, so that's neutral.
But this one is 1, 2, 3, 4, 5, 6, 7. So that one must be the one. It has an extra electron, so it'll get, oh gosh, I can do it. Yes. Okay. It can have the negative charge. Okay. What about, wasn't there something else we learned about last time that was like something with the double bond, and I don't remember what it's called.
Oh yeah, wasn't that like resonance or something like that?
Yeah, that's right.
What is that, Radia?
So we can distribute the charge over the 2 oxygens, I think, and distribute the double bond also instead of having it on the same.
So if I draw it like this, then there's like a thing we do like a curvy line or something like that, right? Okay.
Only 4 will be left now. 4 electrons there.
Okay. Okay, I'm trying to draw the electrons. It's a struggle. Okay, so, and then this one is called resonance. So I'm going to just type that in here because that'll be easier than drawing. Okay, resonance. Good. And we also learned about, didn't we talk about like the bond order or something like,
Oh, right, like calculating bond order for a molecule.
yeah, and I think, didn't they say like, because normally up here it would be like 1 and 2, but then when you have resonance, it like gets spread out, and so then it's like 1.5.
Yeah, so it's like 3 bonds divided by 4 positions, so it's 3/2 is 1.5.
Okay, cool. Okay, I'm gonna save this picture and then
We need our names on the slide, right?
oh, I'll put them in on the slide for sure. Yeah. Where would the picture be? Here? Okay.
Kimberly, you're uploading it.
I think I'm the recorder, so I can upload it. So I've got it on my computer. I just have to put it in the PowerPoint slide. So just let's see. If I come over here, I can just put in the picture.
That's right. So Kimberly, so you'll talk about it if we get called on, if our group gets called on.
Yeah, so what kinds of things do we want to talk about if she calls on us? So we have the structure. What kinds of things did we struggle with as we made the structure?
Oh my gosh. How do I find it, you guys? Where is it? Sorry, go ahead. Sorry, just ignore me.
I feel like it was kind of hard to know to put the double bond unless we because we had all the electrons in the structure, and so I think that was kind of a step that we struggled with, was knowing where to put the double bond and when. So we can maybe talk about how we figured that out.
Yeah, I think that's a good thing. So, Radia, do you have any other ideas, things we could talk about?
Right, about figuring out how to mark the resonance.
I would agree. I think those are the two kind of big things.
Okay, we'll make sure to talk about those if we get called on.
Okay. Thanks, everyone. Raja, I forgot I was supposed to share the file. So I'm going to just find the file really quick and then send that to you guys. I have this slide saved with the drawing on it and stuff. So that way you guys can submit it. Did you guys get it?
Yeah.
If we're done, we're just supposed to go back to the main room, right? When we're done. Okay. Yeah. Welcome back, everyone. Breakout room 1, what did you guys talk about?
So, yeah, we drew the structure following the rules that we had learned in class. So we put the least electronegative atom in the center and surrounded it with the other atoms, hydrogens and oxygens on the outside. We counted up the valence electrons, we got 24 of them, and then we created single bonds and then double bonds as needed. So we got our structure of acetate here. It looked much nicer on the slide. And one of the things that we recognized when we drew this structure was that this was something that we learned about last week, was that there could be resonance between the bonds here, so that the double bond could be here or here, so it's kind of shared equally between the oxygens. So that's something that we noticed after we drew the structure.
Great, thanks very much. That was a great answer, Kimberly. So it looks like you drew the correct structure, and you are correct. There can be resonance there with the C double bond O and then the C single bond O, where both of them could be the double bond. And so in reality, the electrons are spread out across that bond, and we call that resonance, like you mentioned. Okay, we'll go ahead and move on now.